Hello everybody. In this video I'm going to be talking about the modification of an LED light panel. And this is the guts of the first one I built. And I'm going to be modifying that by replacing the LEDs used in the panel itself. The first one I built, I didn't like the color and quality of the light came from the LEDs. So I built a second one using different LEDs and much prefer the quality of the light and quantity of light that came from that panel. So I'm going to be making a new panel to replace this panel, and it will fit into the existing enclosure. So this is kind of a follow-on to the two videos I did a little while back on LED strip lighting. You can check my channel for that. I go into much greater technical detail, including looking at it under a microscope, and I go through the relationship of voltage, current, power, and how that's affected by the length of the strips that you use. So go to those other videos for more detail on that. I'm going to focus in this video on the actual modification of an existing LED light panel. So let me grab the camera and I'll show you my good panel that's currently in operation. So let me pop this out of the tripod, and there you go. So that's the good panel. Now of course the camera has adjusted the exposure, but in any case that's the good panel. And so what I'm going to be doing is modifying the old panel to basically be identical to the good one. So I'll be using a different series of LEDs, and the idea here is this is the panel where the LEDs are actually affixed to. So it's a 1/4 inch, 6 millimeter approximately thickness of MDF. And this is like 450 millimeters by about 300 millimeters approximately. And I have 24 or 25 strips, 400 millimeters in length, to fill out the panel. One of the other things you'll notice here is there's a series of holes at the top and at the bottom. And what that's for is cooling of the LED panel itself. Cool air is brought in at the bottom, washes up through the panel, and then exits out the top. So that's part of the design. And the new one that I'm making, and this is the MDF before drilling the holes in and painting. So this has been cut to size, to the right size. And what I'm going to do is I'm going to be drilling 21 1/2 inch diameter holes at the bottom and 21 1/2 inch diameter holes at the top. Which are a little bit larger than the holes I have here, which will give a little bit better cooling of the panel. So once I've got the holes drilled in it, I'll then sand the surface and sand the edges to make them so they're reduced a little bit, and then I'm going to paint it with white gloss paint, a couple of coats, and the purpose of that is severalfold. First of all, aesthetically makes it look a little better, but also the glossy white surface will reflect light more, so it'll be a little more efficient from the light output standpoint. But the other thing, and this is pretty important with these LED strip lights, is it'll provide a better surface for attaching the LED strips, because they have like an adhesive backing on it, and to try to attach or stick an adhesive surface, a tape, to an unfinished MDF surface, it'll just pop right off in seconds. So you want a painted smooth surface, and glossy is preferable for that. Is a better, smoother surface in which the adhesive on the tape can adhere. So next step on this, having cut it to the right size, drill the holes and then paint it. And then once that's painted and the paint is dried, you'll apply the tapes in online like that, and then you're going to attach. And this side here would be the negative side. So you would attach little strips of wire to the negative terminals on each of these strip tapes. And then on the other side, you run a basically wire that you then attach the positive. So you have the positive coming in at this end and the negative coming in at that end. And that way you reduce your voltage drop, and basically every LED gets basically the same voltage. So that's the idea behind it. And so my next step is drilling holes for the ventilation, a little sanding, and then painting. All right. Okay, out in my shop, got the drill press set up. I've got the 1/2 inch, I think it's a Forstner bit, to cut the holes in the board for the ventilation. I have a backstop in here set to space the bit a 1/2 inch from the edge, and I've got a scribe mark on it so I know where the center line is this way. So I've got marks on the board at each of the places where the holes has to go. So I just need to line up that line with the mark on the back of the backstop and drill it. Now before I actually drill it though, I need to use a backer board underneath it so that when I drill a hole, it doesn't blow out the edges of the hole and mess that up. So you don't want to do that. So let's move this in. Okay. Alright, so nice hole, and it didn't blow out the back of it, so that's why you use the backer board. So I'll do a couple more of these and then we'll shut off the video. No need to see the whole schmear. But we'll do just a couple more and then we'll end the video. I can kind of feel when it goes through the top board. I didn't quite go all the way through. Alright, no point in keeping the camera going for all of this, so I'll bring it back on again when I'm done, and then we'll go back inside. Okay, last couple holes, and we'll be done with the drilling. Last hole. Okay. Okay, so all the holes are drilled, and now I'm going to basically sand the edges to reduce the sharpness of the edges and the corners a little bit, and then the surface itself for preparation for painting. So that's the next step. Okay, time to do the sanding. Okay, that pretty much gets it. One of the things you do want to do is the sander over the holes to reduce the kind of burring around that. So Anyway, this is now ready for painting. So that would be the next step. Okay, so I finished cutting the holes in the board and have painted it white. I used a gloss white, put a couple of coats on it, and then I gave it a light sanding. I've got a center line down it on the long axis because I'm going to be putting 24 tapes on it as an even number. So I'm going to start one above that and then below it. So I can start in the middle and work up and work down from there, applying the tapes. But before I put the tape on, I'm going to apply a coating of adhesive to the painted surface. The reason is the tape, which has, it's got adhesive on the back, peel it like it's a tape. The tape is not really that sticky, and it will tend to come off. So to avoid having that happen, I'm going to be putting a layer of adhesive down, letting it cure a little bit so that I have a stickier surface in which to attach the tape. So in order to avoid putting the adhesive in areas I didn't want to put it, I put some masking tape on it and then cut out a window of the size where the tapes are going to go. So basically this defines the area where the tapes are going to go. So the next step is putting some adhesive on there. I'm going to need to let it cure a little bit, and then I'll apply the tapes. Now, the tapes themselves are 400 millimeters in length, all of them. So I'll be applying them all in the same orientation, and then ultimately I'll have a plus wire, plus bus essentially on one side, a minus bus on the other side, and then I'll be connecting the tapes up at both ends. So in any case, the next step is putting the adhesive on and letting that cure, and then once that's cured, I'll start putting the tapes on. I'll probably let that set overnight before applying or starting to solder the connections up. All right, so I completed the installation of the LED strips on the panel. First, I applied the adhesive. I had the masking tape bordering it so it didn't cover everything. And once I got the adhesive placed, I removed the masking tape and then put the LED strips down one by one. I had a line drawing down the center of the board, so that's really where I started putting the LED strips. Put one right on the line just below it, and another one right on the line just above it, and then move in both directions, applying the tape. Another thing you'll notice here is for example, the top strip is sort of to the left, and then the one below that is to the right. So they alternate left, right, all the way down so that they're not stacked one on top of the other. You don't want to have the LEDs in a perfect line like that. You want them kind of staggered to make for a more diffuse, more even light from the panel. So we got the strips installed. I notched the corners here for these bottom holes so that the wire can go through that. And I'll show you why that was important later. So now we got the board ready. The next step is to install the bus wires and then connect the individual strips to the bus wires. Plus side on this side, minus side on this side, and then basically the panel will be ready to be installed. So that's the next step. There's one more thing that I need to check. And I probably should have done this before I applied the tapes onto the board with the adhesive. And that's to check to make sure that each of the tapes works with electricity. So I've got my power supply set to 10 volts now. I don't need to go to 12, I just need to be able to test it. So minus side on this side, red, plus side on this side. So let's try the top one. Oh, got to turn the power supply on. That always helps. All right, so that obviously works. Then the next one down. That works. Next one down. That works. Next one down. That works. So we just go down one by one. As you're doing that, you want to kind of check to make sure that, first of all, the strip lights, but then also that all the LEDs within the strip light. Ooh, looks like we got a couple that don't work there. 3 LEDs. That should be one group. Doesn't work. So what I'm going to have to do is cut that out and replace that strip. Not the whole strip, just that one segment of it. Again, this would have been better to check before installing. So I'll have to replace that. Basically, like I said, I'll cut that out, peel it out, and then attach another piece. So somehow or another, a segment failed. Okay, so I've got that piece cut out. I've got another piece ready to go in. Let me trim this just a tad more. Make sure it goes in well enough, and make sure I put it in the right direction. There we go. I'll need to solder that in, and I will do that in just a minute. Actually, I'll do that as part of the process of hooking up the strips. So let me mark this so I don't forget. Which one is which. All right, that'll just make it a little easier to figure out which one is which. And I'm not sure what happened to this guy, but anyway, it is dead. All right, I'm going to need to strip off the sheeting on this wire, because this is what I'm going to use for wiring up the panel. So, unfortunately, with a twist in it, it makes it a bit of a pain in the ass to do this, but I've done this enough times over the years. I know how much pressure, how deep to go in. You do have to be careful that you don't cut through the jacket and into your the insulation covering the wire itself. So again, it helps to have practice having done this before, and I have many times. In order to speed things up here, I've fast forwarded a number of times throughout this video. I wanted to show you the whole thing, but you know, you didn't need to see it at real time speed. So I fast forward through quite a bit of this. Takes something of a feel to know how to do this. There we go. All right, so that's the wire stripped. The black will be the negative, the white will be the positive, and so here's the panel. So I'm going to next strip the sheathing off the wire so that it's long enough to extend the length of the strip on both sides. So, and then I'll keep the insulation the rest of the way on it. But I'm going to need to strip off. Oh, let me check my measure here. About, well, let's call it 10 inches or 250 millimeters. Okay, so now we're going to do the soldering And first thing I'm going to do is apply some flux to all the pads to improve the solder connection. So on this side, it's just the negatives that need to be done. And this is an example where having a flux dispenser like this is very helpful. You can put a very controlled amount on there without making a mess, and do so pretty quickly. The other thing I need to do now is basically put some flux on the copper wire that acts as my bus, because I'm going to be bridging between this and the pads on the strips to make the connection. So this needs to be treated with some flux to ensure a good solder connection. So after applying the flux, before I start bridging, I'm going to tin this bus wire. Okay, so let me get some solder. Let the iron back up to temperature. Goes through quite a bit of solder. I'm using 031 solder here. This is the 6337 eutectic solder. For doing board level work, you probably want thinner gauge wire like 020 or even smaller. But if you're doing heavier soldering jobs with thicker wire and whatnot, 020 is just a little too small for that. So getting a little bit thicker wire is a good idea for, or solder is a good idea for doing heavier soldering tasks. I probably should have used a different tip on the iron for tinning the bus wires here. That's like number 10, number 12 wire, so it's pretty heavy. So I should have used a heavier tip iron, a bigger tip on the iron, but I knew I was going to be tinning the pads later on, so I didn't want to do a double change on it. In any case, I did up the temperature of the iron from the normal 350 centigrade to 400 centigrade, and that seemed to have helped a little bit with that. Okay, so that's that done. Now I need to tin the pads on the strips, and I'll start with the negative side. As you'll notice, I tinned the negative pads on the right side and the positive pads on the left side. I could have tinned both pads on both sides and then have a double bus, but it would have been, not much room for running the additional sets of bus wires. So the voltage drop wasn't significant anyway. Okay. So now we got the soldering basically pre-wetting the surface. Now I got to run the wires from the pads to the so let's start with this side here. soldering the individual wires from the buses to the various pads on the strips was a pretty time-consuming process. So again, I sped it up here to avoid having to watch the whole thing. Or you can see the whole thing, but you didn't want to watch it real time. I found that it was more convenient to give the wires a pre-bend before trying to solder the other end of it, so that the little wire was connecting or touching the bus that I was going to be soldering it to. If you didn't do that, then you had to use something to push the wire down so that it was in contact, and you only have so many hands. Last one. And now, actually, I need to solder the piece in that was messed up. I had to cut out. So I'll put some solder paste or flux on the pads. Okay, and the way we'll do this is we'll make a nice little bridge like that, but I need to tin the pads. Okay, probably get away without. That's too big. Easier to just cut it. That's good. I'm using short jumper wires here to connect the pads of the piece that I cut out. The solder itself wouldn't have been a reliable enough connection. So that looks good. That's soldered. The last step is to basically make the solder connection to the... But we'll do that in a minute. I'm going to take a break. Alright, let's see if we can complete this work here. Sorry about that. Complete this work by making the final connections of those little strips to the buses. So I'll start at this end here and I'll just put a little bit of solder on that. Kind of have to press down with the needle nose because it would otherwise burn your hand. Okay, that looks like that should do it. Okay, you'll notice here in a little bit that I found I was not getting a great connection initially with the wires against the bus wire. So I started putting some flux on the tips of the little stub wires and on the bus wire itself to help with the soldering connection. I also used the needle nose pliers to kind of bend the wire. I mentioned that a minute ago, but to bend the wire so that that little stub wire was making physical contact as best as possible with the bus wire. Otherwise, you would have to use something to hold the wire down, and I wound up having to do that anyway in a number of cases. The one major pain in the butt about doing this. I noticed after I finished doing the soldering that about 3 or 4 of the little stub wires on the top right hand corner weren't making a good electrical connection, so I had to go back over that and redo them. And then once I finished that, once I fixed the ones that were not working properly, when I then later tested it, everything was working fine. So you just have to keep an eye out for little errors like that. They do happen. All right, so completed the wiring up. So the solder job is done. And now we need to test to make sure that it works. So I've hooked up the leads to my power supply. The power supply doesn't provide enough power to drive it at full 12 volts, so I'm only going to run it at 8 volts. But in any case, let me turn it on, and there we go. So every LED is on. It seems to be fairly uniform brightness, including the patch where I had the 3 LEDs that weren't working. I repaired that, and now that's working. So let me get down to like 7.5 volts, which should be just about the turn on point. And I'm liking the fact that they're all at pretty much the same brightness. And let me go up to, see, 9 volts. That's about as high as I can go before I push beyond 3 amps on my supply, which is the limit. So that's working pretty good. All right, so really the only thing left now is to put this into the assembly, and we'll have a completed, modified LED light panel. That will be the next step. So let's assemble this now. I've got the frame here. Let me put the glass in. Okay. Now we'll put the this guy in. Sorry for banging the camera there. Okay. Sliding down the groove. Okay. That's in. Put the top on. Okay. Get my screwdriver. Okay, so we have the panel sort of assembled, but now I got to put the electronics portion of it in. Actually, let me kind of go through this by itself. So, what I got here is the control panel, and it's kind of backwards at this point, so let me put it this way. So, power comes in here. This actually connects to a battery, and I'll show you that in a minute. It then goes through a fuse, the power switch, then it goes to the buck converter, and from there it goes to a terminal board, and then out to the LED panels. I also have a smaller buck converter. I really didn't need that. I could have powered the fan off of the same buck converter with some diodes to drop the voltage a little bit. But in any case, I have another buck converter controlling the speed of the fan. So I'll go over how this all kind of ties together when I put it in. So let me move this in a position where I can do that. So okay. So this is going to plug into or attach to the connectors here, terminal board there. I have to trim the wires down a little bit. So power to the LED panel will go into here. The power coming in from the battery goes to the terminal board, then it goes through the fuse switch to the buck converter, and then out from the buck converter to the LED panel. I also have, again, the smaller buck converter for the fan. So I'm going to have to trim that, and I'll come back when that's ready. Alright, so I've got the LED panel fully assembled. The back's on it. And let me rotate this around a little bit. And you can see, hopefully you can see, I've got two LEDs displaying the voltages. The first one shows the voltage coming out of the battery, or at least the voltage as it's received from the battery. And the second one is the voltage set point for the display itself, for the LED panel. And as you can see, that's it. Well, let me turn it that way. Okay, so you can see it's down, let's see, just about 8.9 volts and up to just under 12 volts. I can adjust that if I want to. But for the most part, I run this between about 9 and 11 volts. That keeps the current or the power going through the buck converter below 100 watts. If you go above 11 volts, it's going to draw a little more than 11 volts anyway. You'll draw more than 100 watts. And the buck converter is only rated at 100 watts. But what I've done to try to improve the performance of the buck converter and make it more tolerant of handling higher current is I have this fan. As you can see here, it pulls in air, and then this box assembly is sort of like a plenum. The buck converter is bolted right here, and I have these 3 vents, or 6 vents actually, so that air that comes in from the fan, some of it has to go out past the fins of the buck converter, which does active cooling on it. Does a very effective job of cooling. And looking at the front, and let me increase the voltage enough so that you can actually see some LEDs. So that's just on at this point, not drawing very much current. So that same plenum where the fan brings in air pushes air into the front part of the LED assembly where the LEDs themselves are, pushes them in through these holes, they wash up across the LEDs and then vent out in the holes that are at the top, right here. So the air comes in here, washes up, and then exits out the top. So you have active cooling of not only the electronics portion, the buck converters, for example, but also of the LED panel itself. So this should be tolerant of quite a bit of current, quite a bit of power, and should promote a long life of the LEDs. So that's how it works. And these batteries, these are for my drone, a DJI Inspire 1 Pro drone, which uses these TB48 batteries, and they have almost 130 watt hours of energy, and the voltage ranges from a low of about 18 volts or a little bit more than that up to about 26 volts. So the output of the battery to the LED panel is between 18 and 26 volts. The buck converter then takes that and steps it down to between 6 and 12 volts, whatever I set the potentiometer to. So, and fortunately, the buck converter is very efficient. It's more than 90% efficient. So you wouldn't want a linear regulator in a situation where you're running it with a battery, because linear regulators, although they tend to put out clean power, they're very inefficient. So definitely you want a switch mode type power supply, and a buck converter is in fact a switch mode type power supply. So that completes the modification. So I have the two panels of the same vintage, the same better quality LEDs, and they both put out more power, more light than the original panel. So that completes the upgrade. Thank you for watching.